I'd like to present to you Dick Wilkins with Phoenix, and he is a UEFI board member and a member of the UEFI security response team. He is going to speak to us about risks to UEFI firmware due to growing attack surfaces. Thank you.
Okay, thanks, Rachel. I appreciate that. Again, I'm Dick Wilkins from Phoenix Technologies, and I'm going to reprise something of a presentation that was done in Taiwan because most of you were not there and were not able to see that. Plus, I've made a few updates along the way and have some personal sides to it. But I think there's a bunch of really interesting stuff in this. So, illegal noise. I'm going to be talking about a bunch of different topic areas. Generally, firmware is a target, additional attack surfaces, OEMs adding stuff on top of that, risky implementations, some short mitigation kinds of things. We talked about that. I participated in that webinar for secure coding that I think is valuable to anybody who's kind of new to that space. So if you have a chance to listen to that webinar. And then some suggestions for the future. So you've all heard this before. It's no surprise to anybody here. I'm preaching to the choir, but firmware is a target of everybody out there. As OSs and apps have become more and more hardened over the years, bad actors move to platform firmware, and they've discovered a rich field there. Because if you can compromise platform firmware, nothing is safe. Anything that runs after that point is just can be a victim of code running at the firmware level. It can be persistent. If you can get in there and get into the ROM, it happens every time you boot, and it doesn't matter if you reinstall your OS and all that, it's still going to be there no matter what happens. Over the past several years, the UEFI forum, us, have added all kinds of interesting things to the spec, in particular lots of network stuff. I called out a few of them here. Some folks have added SNMP, and some folks have put the NTFS file system in their firmware, even though Microsoft was nice enough to donate FAT32 to us and for basic usage. Everybody wants to talk to NTFS file systems, so they've stuck them in there. Whether it's completely legal or not is maybe a question, I'm not sure. Anyway, I just snipped a couple of slides from previous presentations here. Companies will remain nameless, logos are visible, but just examples of all the fancy firmware stack, network stack stuff that's gone into the firmware in recent years. Here's some more, Wi-Fi, Bluetooth, the TCP/IP stuff, etc. Why are these features necessary? Well, not fundamentally needed to boot the box. They do allow remote management, network boot, failure recover, all kinds of interesting value-added features that IBVs in particular sell their firmware by adding value over the base spec. So it makes sense. But what are the risks of this? We create all kinds of potential problems when you open up your firmware to doing network stuff before exit boot services, before you have an OS loaded. The Eclipse IAM folks were at Blackhat last summer, and for those not familiar with Eclipse IAM, they're a bunch of folks that primarily left Intel. They're the guys who did ChipSec, and they really know this stuff. And they delivered all kinds of interesting presentations. Network connectivity allows for exploits that don't require physical access to the box. Once you get it over the network, you can be attacked from Ukraine or wherever you happen to be. So examples have been presented in public, so the bad actors already know about them. If they weren't figuring them out on their own, now they're really well aware of them. Many implementations leave dangling ports. I mean, how long have we been telling our server clients, and Microsoft changed its behavior to close all the unneeded ports? Well, gee, in some of the firmware implementation, there are ports wide open that don't need to be there. Someone particularly known to be vulnerable. Do we really need this under all circumstances? And we need to really nail it down when it's required. And just as an aside here, not in the slide, some of you say, well, gee, isn't this sort of kind of hidden? And who's going to be going around probing open ports and things like that? This isn't network-based, but just an example from Blackhat that I found fascinating. There was this guy who was reading Intel patent applications. Sounds really exciting reading. Anyway, he found allusions in a couple of these to an interface to a particular chipset that wasn't publicly acknowledged anywhere. No one had published any information. It was in those secret color cover books that Intel produces for people inside in the know. But he kind of figured out that it must be there somewhere. So he went out on eBay and bought 50 machines with that particular chipset, put them in his office, stacked them up, and ran them for 6 months, probing, trying to identify this interface that allowed microcode access to the processor, got in and found out how to write the microcode with no documentation just by trying it over and over and over again, millions of times, until he had a user mode Linux application that can do about 20 machine instructions that could find his process control block in kernel memory and flip on the administrative rights bit and make him root. And he demonstrated this in the program. I mean, talk about somebody who's obsessive compulsive kind of thing. To spend 6 months and millions of reboots of these machines trying to find just a tiny flaw in the processor that he could get in and make himself root on any machine anywhere using that particular chipset. Scary. And there are people out there doing this professionally, nation-state actors, that kind of thing. If you leave anything open to chance, they'll find it. So back to my slides. Remote management, one of the things we do. Many of these remote management type systems are particularly in the server space. They may be implemented via a BMC, a baseboard management controller, on a private network. It's particularly dangerous because it allows low-level control of loading firmware, drivers, et cetera, et cetera, et cetera, all the different things you can do. And remote management ports, again, when they're not needed. So, BMCs in particular are notorious for being insecure. They use the IPMI protocol specification that, again, is notorious for being rather vulnerable. They depend on being on a private air-gapped network for security. They tend to use really old processor designs, the cheapest thing that they could find, something that's been around, and they haven't been updated or fixed in years in many situations. They don't securely boot themselves, the PMCs themselves, and the firmware is rarely updated. In Blackhat, they showed a demonstration where a system, a server-type system, running a normal OS and application, was able to compromise a vulnerable BMC on that machine and use that BMC to reverse access to their air-gapped private management network and compromised every other BMC on that network and gave a port from the outside world, from the cloud essentially, into that private management network and can control every machine in that network. It's really scary. People in this little group here, some of you, have worked on systems where we provide mail and NTFS access during boot. This was in support, in this particular case, of their OEM's customer services stuff. With this stuff built in, the Preboot software could attach any file from the NTFS file system and email it to anybody in the world in the Preboot. That just sounds a little scary to me. I mean, they could bypass all the security and just email any file they wanted to at any point. Another OEM provided an interface to download EFI apps over a network for hardware diagnostics. The app could be run without signature checks, bypassing the secure boot chain of trust. Some of you don't realize that if you call the load image interface and the image is already in memory, and all you're really doing is asking it to hook it up so it can be run, it doesn't do any security checking of it. None. No signature checks, no nothing. It just says, oh, it's already there. It must have been, somebody else must have done it. I will go ahead and let it be run. So this EFI app could upload results to the customer, to a customer-provided URL. It can be set up to run once or periodically, whatever. But either the download or the upload URL could be spoofed to transfer anything. Any EFI app could be downloaded and run, and that app could send data anywhere it chooses to. No security at all. Gee, it sounds like a really bad idea. So, mitigations, kinds of things for these kinds of things. Pay attention to this. Think about your the attack vectors that you're creating when you add stuff like this. Do targeted code reviews. Where there's a quality, secure implementation available, don't get stuck in the not invented here thing and try and roll your own. You almost always will get it wrong. In previous Plugfests, we've put a bunch of presentations out there about best practices and that kind of thing. Please dig those up and look at them. And briefly, just the obvious stuff. There's a bunch of compiler stuff and things that are out there today, and they've been enabled in Tiana Core, but not by default. You have to turn them on. So things like no execute protection, adding stack cookies for detecting overruns, heap corruption detection stuff, and address space layout randomization. These things should just be automatic nowadays. And you should be doing this on every system you build. Okay, another topic related to this, and this is near and dear to my heart. We've been noting that the model that had existed for a long time out there with OEMs producing updated firmware when they found vulnerabilities or want to extend features or found bugs or whatever, they put together a package and put it on their website and hope that their users will eventually notice that it's there and download it and install it on their machines. And in the past, many people bricked their machines doing this, and so they're resistant for doing it. They don't want to update the firmware. It's scary, and it may well brick their machine, they believe. We've gotten past most of that now, but we need to be proactively downloading security and bug fixes to our machines out there, our customers' machines. We can't wait for customers to download them. So we need a way to do this. So let's just download them off a network. What can go wrong? Again, this comes from the Blackhat presentation. Multiple vendors have added Preboot Code to get updates. They can go to default OEM URLs for updates, and then those can be customized. They can check how often they check for updates. They typically exchange XML or similar type messages and that say, hi, I'm machine so-and-so, do you have any updates for me? And the folks will send back, the OEM will send back, hey, I've got a new firmware update, here's how to get it. Well, what's wrong with that? URLs can be spoofed or replaced. DNS attacks happen all the time. Issues with update signature checking can be exploited if you've got a poor implementation and you're not properly checking your signatures. They'll find a way. Insecure messages can be altered or replaced, directing downloads from anywhere. You can get firmware downloaded from anywhere. Actual testing by the Eclipse IAM folks showed that they could spoof an OEM's site in the cloud, put their own site, put a malformed XML response, and with a trivial change, like a one byte change in a message, could cause the firmware to hang and never boot. And so as long as that system remains connected to the network, you've got a denial of service. It'll never boot. So some OEMs who have attempted this have been forced to disable the functionality in hundreds of SKUs, millions of machines. And of course, just the last couple of weeks, a publication called Motherboard put out this quote. This is the headline: hackers hijacked ASUS software updates to install backdoors on thousands of computers. And there's the details there and a link to the site. You've probably all seen it. If you haven't, you should have. This is just, the guys, probably a nation state, installed bogus firmware updates on millions of ASUS machines because their cloud service was compromised. And this is just, we can't, it looks bad for all of us when this kind of thing happens. Everybody starts saying, how can I trust my machine? How can I trust firmware updates if these things keep happening? So, I had put some stuff out in previous Plugfest, but this forum needs to have some serious discussions about how firmware update gets done. Microsoft has been nice enough to offer us Windows Update, and many OEMs are using it now. That's a terrific mechanism for machines running current supported Windows. It doesn't help machines out there that are running other OSs. It doesn't help with machines running in foreign countries without valid licenses and things like that. It's not an end-all be-all solution, but Microsoft has been nice enough to help us out with some of that. As I said in the previous slide, insecure implementations are no good for anybody. So what do? We as a UEFI organization, do we try and put something in the spec and tell people what they will do? That's generally not what we do here. While it may feel good, it's probably not going to be successful. It's just not the way UEFI does things. It's not our consensus environment. Do we provide example implementations via Tiana Core? That's probably a really good thing to do. Show people how to do it right. Have an open source, visible to everybody, well-tested mechanism that for doing firmware updates, possibly doing the code that inserts in the client, also an example of a service code that we can make available to other folks, to OEMs, ODMs, anybody who wants to update their firmware. Provide white papers to provide clear guidance on secure implementations. Probably a good thing, but people don't necessarily read white papers and all that. I really think providing a good implementation that just works might be the approach. So anyway, we believe that the forum should take the lead on getting this done and getting it done right. So if you're interested in this kind of thing, come talk to me. I'll be around for all 3 days of the event. I'll be around, you're pretty obvious. So come talk to me about it, and we'll see what we can do in this space. Any questions? Hey, Gary, you always have some good questions. I'm good. Gary is retiring, and this is his last Plugfest, and I will miss your good questions.
On the last slide, you said we could specify something in the spec, that would be basically directing people to how to do it. But there's plenty of things we specify in the spec that we don't make mandatory, and it's a toolbox and people can use them if they want. So we could put something in the spec, not make it mandatory, but at least try to push people.
Yeah, we could put a, we have the infrastructure for capsule update and signatures and those kinds of things out there now. And those are optional, et cetera, just like most things in the spec are optional. We could do some sort of a firmware update chapter. There's nothing. But I think using Mark's code first kind of thing is if we had a working implementation that people could see in the open source and then put any specification updates necessary to enable that or to encourage it, that seems like a really good model.
Right, I agree.
Other questions?
Yeah, so while we're talking about code first, the LVFS, which is the Linux vendor firmware system, has an implementation for this that is, at the moment, because of the L, primarily implemented in Linux, but really nothing in the code base that prevents it from being moved somewhere else. And they've discussed ideas of including other information, like maybe like a chipsec whitelist type of thing that comes along with it. So you're not only looking at what type of firmware you're getting, but also some way of a little bit of additional trust. You can do some offline verification in case the signature is involved or not. Do you think that that's something that kind of qualifies as a code first thing that we could start looking at?
Yeah, it sounds like it sounds like a really good idea. And there's a bunch of ideas floating around out there, and I think we should probably, I'm thinking maybe not immediately, but sometime in the next few months, maybe creating an update sub-team to go off and attack these things. I don't know. We can talk about that offline. But one other comment, I was going to say it earlier in the slides when I was talking about the BMC space. BMCs, as I mentioned there, you typically use out-of-date designs, et cetera, software that's been around forever and ever and ever, and they just add a few device support to it or whatever. There is an effort out there called the Open BMC effort that's attempting to create a standard open operating system version for BMCs on all sorts of platforms, et cetera. It's open source, Linux-based, et cetera. And it does use the model that, that various folks were talking about in the ARM space about using U-boot that's tightly coupled with the OS, et cetera. Phoenix joined that OpenBMC effort with the express intent of trying to encourage them to at least use the UEFI-based U-boot environment so that in their code. Right now, honestly, they're focused on trying to get a fairly comprehensive system that will run pretty much on any BMC on any kind of platform. So they're adding device support and basic stuff to it. They're really not looking at booting it, but they're not even talking about securely booting it right now. So anyway, I just thought I'd mention that. Yeah, Gary, go ahead.
So there's another aspect to this. As you say, I'm retiring, so it's not my problem anymore, but you guys are going to have to figure out yourself. Which is what granularity of firmware are you going to be able to update, and who controls that? Right, there's a real problem with the fact that there's no problem with this, but the OEMs like to put it all together, test it really carefully, make sure the whole firmware stack works together, and then issue an update. But maybe we've got a real bug in the firmware TPMs, and now you've got to update the firmware TPM code separately. It's in the system ROM, so now do you take that out of the signed the signed image of the system ROM and have that have its own signature controlled by somebody else, or can it be overlapped so it can be updated by the OEM or somebody else? And the OEMs aren't going to like people updating individual bits of firmware. It's got to be a bit of a mess.
Yeah, I clearly don't have an answer for that question.
Right.
I wish I did.
Pointing out
It's something
a problem
that
you're immediately
we're going to have to address over the next couple years probably, and try and figure something out in that space. So. Anything else? Go ahead, Tim.
No, I got it. I'll bring it to you.
So I think you mentioned BMCs. One of the issues we're running into is BMC's update of firmware.
So we have customers who are asking to be able to audit the firmware, the BIOS firmware from inside the BMC, and how do I know if it's updated? How do I know that its signatures is correct? We're also having, if you have mixed vendors, one BMC vendor, and they're trying to look at somebody else's firmware, how do I go out and verify that that the update I just got over the wire is actually a good one? That it can pass a signature check, and that usually involves looking at a public key which is in the system ROM. How do I find that? Right. So the BMC update of the BIOS ROM image is becoming an increasing thing because we depend on capsule update relies on runtime services executing on the host CPU to get access to the information. BMCs don't have that luxury to make runtime service calls, so it has to be somehow embedded in the binary in a standard fashion, right? All right.
Yeah.
So I think that's another problem that we're running into now.
That's terrific. Actually, some of the things I've been thinking about, and some of us will be talking about, I think, over the next day or two, we'll start to address some of these things. There's some work out there that we can leverage in other spaces that may be able to help us in that space. Again, no answer right here. Anything else? Sounds like we have a lot of stuff to talk about. So, thank you.